Hello students, welcome to the maths class. Today in this video I am going to take the revision of exercise 2C. The revision of exercise 2C. In this exercise you are going to study invertibility. So invertibility I have explained in my previous video, but today in short through questions I will tell you what is invertibility. And some questions of exercise 2C I will explain as revision. Some questions of exercise 2C I will explain as revision. So you see the question. In the question I will explain what is invertibility. You can see question number 2. First of all, invertibility means inverse function. How can you find the given function is inverse function? If the given function is 1 function and onto function, then you can say the given function is invertible function and you can find its inverse. One more time I am telling to you, if the given function is 1 function also onto function, then you can say given function is invertible function and its inverse can be found. So 1 and onto function you have studied in exercise 2a. 1 and onto function you have studied in exercise 2a. Now same thing here you have to show. If they are asking in the question, then show the function is invertible, then you have to show function is 1 and function is onto. So here question number 2 you can see, let the function f which is invertible is defined by fx equals 2x plus 1 upon 1 minus 3x, then show that f inverse x equals x minus 1 upon 3x plus 2. So in the question it is given function is invertible, so no need to show function is invertible, means no need to show function is 1 and function is onto. Directly inverse you have to find. What is the method to find the inverse? I will tell you. You see the solution. Given function is fx equals 2x plus 1 upon 1 minus 3x. So you can take this given function as y. So let y equals fx. Fx value you can put y equals 2x plus 1 upon 1 minus 3x. Now do cross multiplication. When you do cross multiplication you will get y minus 3xy equals 2x plus 1. Take the terms having y on one side, take the terms containing x on one side. So y minus 1 equals 3xy plus 2x. X is common, 3y plus 2 inside the bracket it will come. So by simplifying you are getting x equals y minus 1 upon 3y plus 2. Now you have to replace this x by f inverse y. This x by f inverse y. So f inverse y equals y minus 1 upon 3y plus 2. Now f inverse y, in place of y you put x both the sides. In place of y both the sides you put x. So f inverse x equals x minus 1 upon 3x plus 2, which is the required inverse. Which is the required inverse. Next question you see, fourth question. If fx equals 4 minus x minus 7 to the power 3 whole power 1 upon 5 is a real invertible function, then find f inverse x. So here also invertible function is given, so no need to show the function is 1 on 2. Directly inverse you have to find. How to find inverse? Just before I told you, same method you will apply. You can see the solution. Fx equals big bracket start 4 minus small bracket starts x minus 7 to the power 3 whole power 1 upon 5. You can take this function as y. Y equals fx, y equals 4 minus x minus 7 to the power 3 whole power 1 upon 5. Now after this take 5 power both the sides, or you can transfer this 1 upon 5 power to LHS. So it will become 1 upon 5 will become 5. So y to the power 5 equals 4 minus x minus 7 to the power 3. Now take this x minus 7 to the power 3 to LHS. and this y to the power 5 to RHS. So x minus 7 to the power 3 is equal to 4 minus y to the power 5. Now take cube root both the sides. So x minus 7 equals cube root of 4 minus y to the power 5. Now 7 you take to RHS, x equals cube root of 4 minus y to the power 5 plus 7. Now replace this x with f inverse y as you have done in previous question. So f inverse y equals cube root of 4 minus y to the power 5 plus 7. Now in place of y both the sides you put x. So f inverse x equals cube root of 4 minus x to the power 5 plus 7, which is the final inverse. So like this you can find inverse. Now sixth question, you see what you have to do in sixth question. If f such that R to R is defined by fx equals x cube, then find f inverse 8. You have to find in this question f inverse 8. So first of all you find f inverse x, then value of x you put 8, then f inverse 8 you will get. So fx equals x cubed, let y equals fx, then y equals x cubed, take both the sides cube root, x equals cube root of y, replace x by f inverse y. So f inverse y equals cube root of y. Now in place of y you put x, so f inverse x equals cube root of x. Now both the sides you put 8, value of x as 8, because you have to find f inverse 8. So f inverse 8 equals cube root of 8, which is 2. So simple question it was. In all three questions which I have explained, same work was there, inverse you were finding. So here now seventh question, you see. In seventh question, if f such that R to R is defined by fx equals mod x, then four options are there. Option A, f inverse x equals minus x. Option B, f inverse x equals 1 upon mod x. Option C, f inverse x does not exist. Option D, f inverse x equals 1 upon x. So which option is correct? You have to tell in this question. Function is given R to R and defined by fx equals mod x. So I have written here solution, you can see f such that R to R defined by fx equals mod x. First of all, I will check this function is 1 1 or not, because one option is given, f inverse does not exist. So it means that it is not said in the question, then given function is invertible function. So when it is not said in the question, given function is invertible function, so you will have to check it is 1 1 on 2 or not. So for 1 1 I have taken x1 and x2 belongs to R such that fx1 equals fx2. In exercise 2a you have shown how to show this method. I told you in exercise 2a how to show a given function is 1 1 and on 2. So same method I am applying here. Two elements from the domain I am taking, x1 and x2 belongs to R such that fx1 equals fx2. fx1 means mod x1, fx2 means mod x2. So mod x1 equals mod x2. Now squaring both the sides, x1 square equals x2 square. So x1 equals plus minus x2. So x1 is not exactly x2, is not equal to x2. x1 is equal to plus minus x2. So that's why I have written here, thus fx1 is equal to fx2 does not imply that x1 equals x2. So for example also I have told you, if you are taking x equals 1, so f1 will come mod 1 means 1. If you are taking x equals minus 1, so f minus 1 will come mod minus 1 is also 1. So it means that two elements 1 and minus 1, they have the same image 1. Two elements 1 and minus 1, they have the same image 1. So when two elements are having the same image, so it is not 1 1 function, f is a many one function. F is a many one function. So when it is many one function, no need to check it is on 2 or not, because for invertible function must be 1 1 and on 2. So when it is not 1 1, so no need to check it is on 2 or not, because when it is not 1 1, so its inverse will not exist. So that's why I have written f inverse x does not exist. So option C is correct. Option C is correct. Now question number 9, you see, show that function f such that closed interval minus 1 to 1 to r given by fx equals x upon x plus 2, x is not equal to minus 2 is 1 1. Now you see students, in this question this function is given 1 1 for which domain is minus 1 to 1 and range is real number set. Find the inverse of the function f such that minus 1 to 1, domain is minus 1 to 1, closed interval, tends to range f. It means that function is same, fx equals x upon x plus 2. Here f was from the closed interval minus 1 to plus 1 to real number set, and means codomain was real number here, and for which you have to find inverse. Here codomain is range. So how to solve, you can see here. Since f such that closed interval minus 1 to 1 to r such that fx equals x upon x plus 2, x is not equal to minus 2 is 1 1. It is given, this line is given, this step is given. So therefore f such that minus 1 to 1 closed interval to range f, fx equals x upon x plus 2, x is not equal to minus 2 is also a 1 1 function. Listen students, when function is same x upon x plus 2, domain is also same. Here range, here codomain is r, and from this codomain range will be made, and in second step already they are giving range. So domain to range, this will also be 1 1 function when first one is 1 1. Now on to when codomain equals range, in place of codomain range is given, for which you have to find inverse. Again and again I am saying, for which you have to find inverse, codomain equals range, it is given. So that's why I have written here codomain equals range. So f is on to, so f is 1 1, f is on to, so f is invertible. When f is invertible, so you can take y equals fx. So y equals x upon x plus 2, cross multiply xy plus 2y equals x, 2y equals x minus xy, 2y equals x into 1 minus y. So make x subject, x equals 2y upon 1 minus y. Now replace x by f inverse y. F inverse y equals 2y upon 1 minus y, and y is not equal to 1, because if y will be 1, then this function will not be defined. This inverse will not be defined. So that's why we can define it 2y upon 1 minus y. Y is not equal to 1. Now in place of y you put x. So f inverse x equals 2x upon 1 minus x, and x is not equal to 1, which is the required inverse, which is the inverse of the function asked in the question. So like this students, some part of this exercise I have taken today, and some part of this exercise I will take tomorrow in my video. Then this exercise will complete, because this exercise, in this exercise 2-3 types of questions are there. So one type of questions I have taken today, remaining type to second type questions, second and third type question I will take tomorrow. So till question number 9 you solve the remaining questions. 4 questions I have taken here, 4-5 questions. Remaining questions you solve. If you have any problem in solving the remaining questions, you can ask, I will clear your doubts. So thank you and have a nice day.